G'day, this is the last video on circle theorems and angles in circles and all that sort of stuff. This is theorem 9 that I'm going to cover in this video today. Now imagine we have a circle here and we have a tangent from P to T, and we have this other line here, the secant, that goes from P all the way through to B. There's obviously a chord from A to B. Now this one here, I'm going to compare this length here from P to T with P to A and P to B. So let's get started. Again, I need to make a couple of assumptions or a couple of observations. I'm going to say that this value in here is x, this angle, and this one in there is y. Now based on theorem 7, if this is a tangent, this line here, this angle here, x, will be exactly the same as this angle over here. And we're going to call this angle A, this angle Z, and therefore this angle in here must be 180 minus A. Okay, now let's just look at this triangle here, this PTA triangle. I know that x plus z plus 180 minus A must equal 180 degrees. Okay, 3 angles in a triangle. Now, that 180 and that 180 can eliminate themselves because they're on each side of the equation. So I've got x plus z minus A equals 0, or x plus z equals A. Now let's just have a look at this for a second. Here's z, here's x. This one plus this one equals this one over here, which sort of makes sense. Well, at least it does in my mind. That one plus that one must equal this one. So I guess in this case, the other angle must be true as well. So y plus x must equal 180 minus A. Now, if that's true, I can then replace 180 minus A with x plus y. And now I'm going to have two similar triangles. Let me try and draw them out for you. I've got this triangle, big triangle here of PTB, and this angle in here is going to be z. This angle here is going to be x, and this angle up here is going to be x plus y. Okay, and then I'm going to have this other angle, which I'm going to have to rotate a little bit just so that it looks nice. Sort of do this in my head. I've got this other triangle that is z, x plus y, and x, and that's going to be t, a, p. So I've sort of rotated it a little bit in my mind. Okay. And now, again, I can use some similar triangles. Remembering that what I'm trying to compare is this PT side here with PA and also PB. So let's do that. I can say that PT divided by PB must be the same in the same ratio as PA divided by PT. Now I've got all the lengths that I want, so now I can multiply both sides by PT. So I get PT squared is equal to PA times PB, and in fact that is the rule, or that's the theorem that we've got, that this side here squared is equal to this length multiplied by this length over here. Okay, and so we end up with this theorem 9. Point P is outside a circle, and TAB are points on the circle such that PT is a tangent and PAB is a secant, then PT squared equals PA multiplied by PB. That's exactly what we've just proved up here using this diagram. Okay, so hopefully that has helped. Let me know if you have any problems. Thanks.